Hello. Today's video is going to be all about the electronics in this drone. I actually ended up filming this in reverse, where I'm filming the intro after I built the drone, and had a little help from Ben on different components. He's not here today, so I'm filming the intro on my own. But essentially, this is what we end up with, right? So we're going to end up building all this, installing the receiver, the video transmitter, the GPS unit, battery, flight controller, and I'll walk you through how everything got mounted in there and get it ready for its first flight and for tuning and so forth. So we won't actually fly it in this video, basically getting everything all built and showing you how to construct it and package it all up. And then next video, we should be able to figure out how to tune it and fly it. So let's head on over to the workbench and get started. So I want to walk you through the electronics for the drone. I went ahead and did this offline. I needed to do some research on the different wiring configurations and ports that everything connects to. And it would just take too long to film all that and you'd be bored. But I can show you the finished product here and how things came out. So the first thing that you're going to do when you get your MicoAir, so remember it comes in this box, is it will come with the capacitor, and it will also come with the red and white wire and the XT60 connector. So you're going to solder that to your speed controller. All right. And so it will be labeled plus and minus where the positive and negative go. Red wire goes to positive. Black wire goes to negative. And your capacitor will also solder to that same spot as well. You got to be careful. The capacitor also has polarity, so the negative side is labeled on it, and you're going to end up making sure that that's connected to the negative input on the speed controller. Okay? And the other thing I did on this capacitor, I don't know if you can see it, but I put a little heat shrink tubing over the bare wires there, just to give it a little extra protection. So you're going to solder, those four connections there, the two wires and the capacitor leads. And then on this side, for your connector, you're going to solder your positive and negative terminals to your XT60 connector. And make sure you put this little gray plastic piece over the wires first before you solder it, because then you're going to pull that up and it just kind of snaps over and covers it all really well. Now, the XT60 connector, I don't believe is labeled, but to get it right, I always just end up looking at a battery that tells me where the positive and negative are, and I line it up so that as I'm soldering and looking, I make sure that I get connections to the right leads. So it ends up that the negative side goes to this little rounded section, right? So kind of goes like that. All right, so that's your speed controller, right? And before I hooked anything else up, I have a smoke stopper that I use. I don't have it in this video, but it will look for shorts. And I also, let me show you this real quick. I also use a continuity tester when I'm soldering things up. So I got an old Radio Shack multimeter here, and you can put it in continuity test mode. And I don't know if you can see that there. It'll tell you the resistance. If you tap the leads together, it'll beep because there's a short, right? There is absolutely no resistance going through. So what I do after I end up soldering power leads to things is I will just put the continuity tester on the both power pins and make sure that I don't have a direct short to begin with, right? And so you're seeing a little bit of resistance on the meter as it's floating around, but it isn't beeping and telling me that there is a short. If I were to plug it over, put them on the same pad, you're going to get a short and a beep. Okay. So that's how I check things before I even plug in a battery to verify that I don't have a short circuit. Okay. So now you have your speed controller done. You've got a battery connection that can go to it. Now you got to have the rest of the pieces ready to go. And so on the MicoAir flight controller, one thing that I found is that this micro SD card comes loose. I might actually put a little bit of hot glue or something on that. I'm not sure yet. Or a little bit of E6000 just to hold it in, to kind of tack it in so it doesn't move. And with this, now I'll walk through the different connections, but your MicoAir flight controller and ESC will come with this cable here that will connect between the two, okay? So there's only one port that it can connect to on the ESC, but there are two ports that it looks like it fits into on the flight controller. You need to get it, if you're looking at it in this orientation with your micro SD card going up, you need to get it in this top port here. And if you look real close, I don't know if I can get this in focus or not, but that top port is labeled ESC on the board. It's just really hard to see. It's really tiny text. So this wire goes between the two, and just make sure that you get it oriented correctly before you plug it in, because if you plug it in upside down, it's not going to fit. But if you try and push it in really hard with it upside down, you might end up bending some of the pins in there. So just be very careful. All right, so let's talk about the rest of these devices. I'll probably start with the easiest ones first. So your GPS, this is the MicoAir M10 GPS. This came with a cable that is already designed to fit and work and only fits one way into the MicoAir flight controller and the GPS unit. So, take the cable that it came with, plug it right into that port there. And then the other end goes into the port labeled GPS on this flight controller, which is down here. Okay. So you can see how it plugs in. All right. The next item, which was a little bit trickier, was the ELRS receiver. So this receiver only came like that, right? No wiring or anything. It came with little solder pads, some heat shrink tubing, and an antenna. So what I did was in your MicoAir box, so this thing here, right? It came with a bunch of extra wires that had the 4-pin connector for all these different ports. So under here, right, you get a bunch of them. Now, take that wire. I took one of them. Let me put this back here real quick and I'll show you. You take one of these wires, and what I did here was I just snipped the end off of one side of it and stripped the wires. And so I'm left with a connector that would go into the MicoAir, into this port here, plug in, and then I soldered the wires to the right pins on the ELRS receiver. So you might be able to see the pin out here, but black goes to ground, red goes to the positive 5 volts, green went to TX, yellow went to RX. Now, if you're making your own custom cable and you're wiring this thing up, just be sure when you're looking at the pinouts that TX from the flight controller connects to the RX port on the ELRS receiver, and vice versa. The RX port on the flight controller connects to the TX port. So you gotta cross those wires. All right. So once you do that, you will have your receiver connected up. The next piece then is our RunCam. So this RunCam came with a couple cables here. So it came with this one here up to this connection here, right? So it ended up with a yellow, black, and red connection. And what I had to do was, off of Amazon, I bought a cable that has the other side, the connector there. And let me look it up and see. I bought this little kit. I believe this is the right one here. It's an MX connector, I believe. So if we unplug this, right, and then you want a 3-pin MX connector that will fit into it. And so what I did was this kit from Amazon, right, comes with the different style connectors. And it also comes with pre-crimped wires. And what you do is you insert the wire into the connector and you can build your own wire. So what I did was I built this side, right, where I plugged in a black, red, and yellow cable into that connector. And it's oriented like that, right? If the pins are closest to the top right now, and so the orientation is red, black, and yellow. And I did those colors just so that they align with the same colors on the RunCam, right? So when I connect those two together, that's what I get. Now, on the other end, you can see in the middle of this wire, I've got some heat shrink tubing. And that is because on the other side, I took the 3-pin connector, that cable that came with the MicoAir, and I cut the other end of the connection off, right? So I ended up with red, black, and yellow. And what I did was I just soldered the wires together in between then. So if you're following that model, right, the colors all line up on this cable where red goes to red, black goes to black, yellow goes to yellow, and you'll get it right? You can follow those connections that way. But in case you want to see the pinout, this MicoAir pinout is available online, but it's, you know, looking from this orientation here, positive 12 volts, I believe, actually, is on the far right, ground in the middle, video signal is on the left. And then, you know, same thing with your RunCam, you've got those 3 wires. All right, and be careful, it is a 12 volt connection coming out of this MicoAir from the BEC for the camera. So if you do get a RunCam, just make sure it can handle the 12 volt input. I believe this one does. I can't remember if it handles even higher voltage or not off the top of my head. Okay, and now the last connection here is the video transmitter. And so this thing, this Team Black Sheep video transmitter, this is the HV version. It's the high voltage one, I believe, because it runs off of 12 volts instead of 5 volts. And so that one, you know, first of all, I got these antennas from Team Black Sheep as well. Your video transmitter comes looking something like that, with video transmitter wrapped in plastic and an antenna wire. Take your antenna and connect that there. Okay. And then your video transmitter also comes with a cable where it has the right connector to plug into the video transmitter unit. And there are several wires. So these left ones here, the positive and the negative wires, those are the inputs. Those are the first 2 pins from the left-hand side here. The next 2 we don't use. It's also, it's power out, positive and negative. That's in case you want to just plug your camera right in off of this thing and feed it from the power supply. And then there's some sort of, I think, control signal wire. And then there's a yellow. Well, actually, yellow is next. Yellow is your video signal. This green wire we're not using, some sort of control signal. And the white is the smart audio connection, I believe is what they call it. And so those wires, this is the funkiest one that didn't really look nice because I had to flop some of the wires around. But on your MicoAir, the way these pins come out on this one is the way the cable lined up, the black wire is actually the positive voltage coming out of this MicoAir, and the red wire is actually the ground. And so you can see when I wired those 2 together, the red is going to a black cable and the black is going to the red cable on the video transmitter side. So you just got to be careful and pay attention to the pinout. I didn't want to build a new cable. I already had them here, so I'm just living with, you know, the wires coming out of the MicoAir. Look backwards until you hit where I soldered it to the new cable. Then it's correct. The other ones here, you want to connect yellow to yellow. and that's your video signal going in, and then green went to the white wire here for your smart audio connection. So I'm not sure if you'll be able to see that well if I just lay the whole thing out here, but that's what it looks like. And these 3 wires here are just not used. I'm probably going to snip those off even shorter when I mount it in the drone. Okay, so with that, you got kind of a working system here, or your electronics all wired up at least. And you can go ahead and, as long as you test it and make sure you don't have any shorts, you can power this thing up. So I'm going to just lay these out like that, clean it up a little bit. There's my speed control to the flight controller. I got a 4S battery here that I'm going to go ahead and just connect in. We'll see it power up. So your MicoAir has a little blue light that comes on it. Your GPS will have a blue light. Your receiver should be flashing green when it's looking to bind to a transmitter. Your video transmitter has a blue light on it as well. If I kill this light, maybe you can see how it lights up a little better. And that is essentially the wiring. So still got to configure ArduPilot and install it and everything, but that is how the electronics are going to get connected to each other, and then we'll bundle this into the drone. So I'll pause the video here. We'll pick up in a second. I'll show you how I started to modify the Protek frame as well to be able to hold these devices. See you soon. Now, the next challenge we had to overcome is how to fit this flight controller and electronic stack into the Protek frame. And by default, this thing is made for, I believe, a 25mm flight controller oriented kind of in a diamond pattern, where, you know, it's more like that rather than kind of just a flat square. And the flight controller here is more like a 30mm, I believe. And so what happened is, if you just tried to lay things in there as is, it didn't line up with any of the existing holes, and it wouldn't go down far enough because there were little tabs off these fan or prop guards that are designed to hold a DJI Air unit. And so, you know, they're in each corner pretty close to where each of these aluminum or brass standoffs are that I have right now. So what I did was I took this apart and I pulled these prop guards off. And I don't know if you can see it in this picture, but see where it's all scuffed up kind of right behind that brass standoff? I used a Dremel grinder, sander, whatever. And I just ground off those tabs, right? So on all 4 spots, I had to grind off that plastic so that it was just flush with the fan guard. And so you can see, I think, in each of these, just kind of where I did that. Try and get some angles. It's just the scuff marks on each of these. So it ends up grinding off very easily. You could probably use a little hacksaw if you didn't have a Dremel and sandpaper and get there as well. I'd say just take it slow so you don't grind all the way through the plastic. So then that created some space where now my 30mm devices will fit in there and lay nice. Next challenge was I wanted to have a little bit more space so that I can run cables underneath it if needed. And in fact, that's where I'm going to put the video transmitter ultimately. And so what I did was I laid my speed controller in there and marked where the 4 holes would be. And I used a drill press just to drill 4 new holes into this frame where I can screw my flight controller and speed controller to. Okay. And then I use these brass standoffs. These are just off of Amazon. I think they were, I don't even remember what they were called. Just Raspberry Pi brass standoffs, I think is what I called them. And they give you a little kit with different sizes and screws and so forth. And they work perfectly. They fit a 2.5 millimeter screw, I believe. So, or M2.5 screws. So these are what the screws I was using then too, that will mount the flight controller to it. So the way this works, or is going to work, is the video transmitter I'm going to lay on the bottom here. Okay, and that gives me a nice little space where this is then going to come out the back. And I'm probably just going to use double-sided tape or something to hold that down. Okay, and then I'm going to stack the ESC on. And on your ESC, you can see there's some rubber pads already in it. Those are going to go towards the bottom. So they will line up with those aluminum standoffs that I have. And then lastly, the flight controller. And the flight controller does have an orientation to it, so you got to make sure you get that right. There's an arrow. I have to pull the video transmitter out so I can get it closer. There's an arrow on it that points to the front of the drone. Okay, and so when we mount all this, we're gonna have something like video transmitter, ESC, and then the MicoAir unit. Okay, and that'll all just fit so that then the top of the drone can go on and screw back onto this thing. Okay, and then to hold it all together as well, the reason I showed the screw kit earlier, I used some M2.5 by 20 screws that came in this kit. That's just off of Amazon. Search for M2.5 screw kit. I have, you can get a hex head or a button head, I believe. These are the button head ones. Okay. And these will just go through all of these rubber holes. And make sure you line it up right and you don't got any wires pinched in between where you're screwing stuff together as well. But ultimately you can screw that to the brass standoffs, right? And it'll hold it all together. And that's how you're going to mount your electronics. Now, we still got to run the RunCam, which will mount up front. I'll show that in a future video. The GPS is going to come out the back. And so is your transmitter. Okay. So that's kind of how all this will end up working, and a bunch of wires to kind of manage and get lined up in there well. Let me pull this off real quick. Okay, so there's a speed controller, the rest of our electronics mess that we got going on there. The other thing I didn't talk about very well were these brass standoffs. So, like I said earlier, I did just put the speed controller in there, mark where the 4 holes were, and drill them. And the brass standoffs just kind of fit through. And then I used these little M2.5 button screws as well on the bottom that connect to the bottom of the standoff. So the standoffs that I used there are the ones with a female end on both, right? So I can screw into both sides there. I did not use these ones that have both a male and a female end, right? So that's how that went together. You know, next steps that I need to figure out are how I'm going to connect these motor wires, because that is going to be a little tight, but from what I can tell, it will work. And I'm trying to debate right now, do I want to use these little 3-pin connectors and maybe cut these wires so that I can solder smaller wires and connectors to each of the pads on the ESC, and then do the same thing on the other end on the motors, and then I can plug them together and unplug them if I ever need to replace a motor, rather than trying to work in this tight area and solder and unsolder wires. What I don't know though is that comes with extra weight, comes with extra stuff that needs to get mounted into the drone. So I'm not sure if I'm actually going to do that yet, or if I'm just going to screw the speed controller down and mount the wires in and solder them directly yet. Still TBD for that. Okay, so that's where we're at right now. And I think I'm going to start assembling some of this and showing how we get all the electronics mounted in here then, so that we can get the final assembly done and then start tuning and flying this thing. All right, be back soon. So I did a little bit of work looking at how this best fits in and so forth. And I decided to go the connector route. So what I did was I cut 12 small little 22 gauge pieces of wire. I don't know, 2 inches long or so. And what I'm going to do, I think, is I'm going to take each one of these wires and I'm going to kind of run it to the inside of the ESC. So I'm going to solder them to each of this, and I'm going to run it at an angle so the top two kind of go up towards the front, and then the bottom two kind of go towards the back. And then what I'm going to use are these connectors, these 3-pin connectors. And so I'll have 2 in the back, 2 in the front, that I can then wire the ESC to the motors. So, and I did that for one reason right now. It's probably wish I did it differently later, but I don't necessarily know how these motors on this board are going to map to ArduCopter. I don't know which one is motor 1, 2, 3, and 4 on this board. It does have them labeled, where it says on this board, there's a, let's see, what does it show? Down here is number 1, number 2, number 3, number 4. But I don't know if that's really how they're going to map out. And so I want to be able to easily reconnect the motor to the ESC in case something is not on the right port. So that'll let me just unplug the connection and reconnect it to a different motor. So yeah, so I'm going to stop the video here. What I'm going to do is hook up the 12 wires to this ESC and solder them to these connectors, and do the same with the motors, and just try and get it all wired up, soldered, so I can show you how it all fits in here then. So that'll take me a little while, but I'll be back soon and show you an update as soon as I have that done. Here's a little bit of an update of the work in progress. So I went ahead and I put a blob of solder on each one of the ESC motor pads, and then I have all my 12 wires cut and I tin the ends of those. So what I'm going to do then is I'm going to start connecting and soldering those to each piece of the ESC so I can kind of route it out and around. So I'll keep soldering and show you what's next. Okay, all the wires are connected, soldered to the board. Here's just a quick shot of what that looks like. Don't make fun of my soldering. I put a continuity tester on all the pads as well, just to make sure none of them were shorted out. And they're all looking good so far. So you can try this as well real quick. And just plug it into a battery, see if anything smokes. And so far nothing, so I think we're okay. So now next up, I'm going to put the connectors on each end and on the motors. Be back in a few. All right, I finished up soldering up these connectors and just want to show you what it looked like. So each motor now has one of these 3-pin connectors on it. I put the male side on each motor. Okay. And then When I did this too, I also cut about 2 inches off of each of the motor wires just to shorten it up so there's not so much wire inside of the drone frame. And then we have this, which is the speed controller with all 4 connections as well, with a female end on each side. So should be able to put that in, screw it in, and connect all the motors up, and then hopefully they work. So I want to show that. I'm going to pause real quick and figure out what my next steps are going to be here, and we'll continue recording. Okay, before I go any further, I wanted to just connect the motors and kind of just set the electronics in there so that I can use the USB connection, connect for a mission planner, and test the motors. So this flight controller already has ArduPilot on there, ArduCopter, the latest 4.6.2 version. And the front of the drone is here. Okay, so this is the rear. And you need to be careful when you look at the ArduPilot documentation. Your motors go A, B, C, and D. Okay. And each one of those motors has a spin direction that has to be correct, of clockwise or counterclockwise. And so what I did is I put a little piece of tape on each shaft, and then in Mission Planner I went and did the motor test. So if I go test motor A, for example, and it should be spinning there. I got it at 1% throttle, so I can see that it's going clockwise with that tape spinning, and for 5 seconds. And if I go test motor 2, I'm sorry, actually motor A is supposed to be counterclockwise. Let's just verify that real quick. Okay, so that is going counterclockwise. Motor B needs to be going clockwise. That appears to be spinning in the right direction. Motor C is counterclockwise, which is spinning correctly. And then motor D is going to be clockwise. And that one's correct. So, it seems I got lucky, maybe, in that all the wires were connected up correctly. I did not have to change any of the connections here. So, in the ArduPilot configuration that I'll post for this video, in the wiki on my GitHub, I did have to remap these ports. So you have to set the servo X function according to the MicoAir documentation, and then the stuff just works, right? It'll treat them as motor A, B, C, and D from each corner of that board. The other thing that I was saying, I got lucky, the motors all appear to be rotating in the correct direction. If for some reason the motor was spinning in the wrong direction, all you got to do is just swap 2 wires, any 2 wires, and it'll reverse the order of the motor. So that's kind of where this is at. So I'm going to go ahead, call this a working prototype right now. And then the next step is we'll start to mount the electronics in there and seal this thing up, see if it can fly at some point. So be back in a minute. In the last segment, I did a motor test, but I realized not all of you may have be familiar with Mission Planner and being able to set the parameters in ArduPilot and so forth. So I want to show you a little bit about how I got to that point. What you're going to need is go to my wiki here for this project. So in the YouTube description, I have a wiki page or a link to this wiki that should take you here to the FPV drone build project. And you can click on this link down here for the documentation folder. I'm going to go to that. And For each video that I produce in this series, I'm making a folder, 01 for the parts overview that we took a video on and the frame assembly. This video here is the electronics. So I want you to expand that folder and go to the electronics wiki page here. Now you'll get to a page that looks like this where I have a bunch of the build notes. And so far, what you're going to need to know are the pieces under this flight controller and ESC setup. So if you're not familiar with the ArduPilot ecosystem, you're first going to need to have this mission planner software. So I put a link to the ArduPilot website where they give you a link to be able to download and install it. So follow these instructions, download, install it, and set it up. What you should be able to do then is I have a USB-C connection to my drone right now between my drone and my computer, and I also have it powered with a battery. So if I go to Mission Planner, like if I start this app up here, it's graphing some of the telemetry and stuff right now, but if I disconnect, right, what's going to happen in Mission Planner is that when it launches in the upper right here, you should see a COM port listed for your USB connection. Yours might be COM 6, COM 7, COM 14. It isn't always the same as mine. In mine, it registered as COM 8, so I'm going to go ahead and pick that. And then when I pick connect, and set your baud rate to 115.2 as well. It might default to 57.6, I can't remember. Set those two and you hit connect, and it should go off and connect to your flight controller. Now, if you haven't installed your mission or your ArduPilot firmware for the first time, you'll need to do that. And the easiest way to do that is if you disconnect and you're connected through USB-C. So I'm not connected at this point. If you go to setup, you can go to this install firmware tab, and we're going to pick Copter version 4.6.2 official, right? And that'll go download it and install it on your flight controller. If you bought it from the MicoAir website too, it might already come with the firmware. That is an option. I did install the latest 4.6.2 firmware on this board though. So I'm going to go ahead and reconnect, right? And here's the telemetry. You can see it's leaning a little bit on my desk. Ultimately, what you're going to need to do, though, is set a bunch of settings in ArduPilot to tell it how your hardware is configured. And so, oops, I'm on my Visual Studio Code environment here. What I want to do is on the wiki, right? So I have a page here with the ArduPilot configuration that'll list you through every property we need to set to make this happen. Before we do that, though, let me give you a couple of these other links that are helpful. So remember how I talked about the motors A, B, C, and D, what position they need to be in, and what direction they need to spin in? If you go to that page, you can see here's the front of the drone for a quad X. It's got the different drone patterns here. We're doing a quad X. You can see motor A is the front right, B is the rear right, C, rear left, D, front left. Okay, this little arrow is pointing to the front of the drone. And so these are your motor numbers, 1, 4, 2, and 3, and A, B, C, and D is how ArduPilot refers to them as. Okay, that'll come in important later when you're doing your motor test and you got to remember which direction they're supposed to be spinning in. Whoops, I'm sorry. It'll also show you, here's the counterclockwise, this one should be spinning clockwise, this one's clockwise, and so on. Okay, so next, you should also, before you do all this electronic work, read the MicoAir documentation. So if you go read their Getting Started guide, and I'll pop that open. This is a really great page where they list a lot of the information on what to set up in ArduPilot, what to pick, how to deal with your speed controller, and so forth. A lot of these settings I'm just going to give you on my config page so that you can just type that in and hit save and it should be in there. Okay. It also talks about remapping the motor channels. I had to do that as well, and it all seemed to work. Okay. The other thing I want you to be aware of before you solder together all your connections are the pinouts of this controller. So I'm going to go to the page. This is the store, but if you pick your 60 amp Bluejay stack, which is what I bought, anyway, down here are the pinouts for every one of these ports. And, excuse me. And if you remember, for example, the video transmitter port, right? Which one is 12 volts? Which one is ground? Remember in the previous segment, I talked about how they didn't really align with the actual red and black wire. The black wire on the default connection was going into the 12 volt port. So you got to pay attention to how these things are wired and make your connections correctly. It'll also tell you what your UART ports are and the connectivity for those as well. And then if you keep going down a little bit, it'll show the back of the board, right? And so here, for example, the FPV camera connections are right here. So you got a 12 volt power source there, ground, and the video in port. So this is where the RunCam is connecting to. So that is all useful. Here's a high level connection diagram as well to how everything should be wired up. For example, where the GPS connection goes. We're not using the DJI Air unit. We're actually using a video transmitter and a separate camera. So if you see, for example, this diagram where they're showing the DJI Air unit, we're not using that connection there. Okay. So that brings us back to my wiki page, right? You did a bunch of reading. You understand how to connect to your flight controller. You got the firmware on there. Now you need to set your appropriate configuration parameters in ArduPilot. So that would be this link here to the ArduPilot configuration page. So I talk about a lot of the same stuff here. The getting started guide and the same documentation on the MicoAir 743. Okay. So this is the ArduPilot documentation of what I was just showing. But what you want to do is if you scroll down, I'm giving you a lot of the settings as you go into Mission Planner. So let's see if I stack these side by side. You probably hear the inactivity alarm on the drone is beeping in the background right now. So I'm walking you through what to do here, right? Go to the Setup tab, expand the mandatory hardware. On the frame type, select Quad X. So that would be this pattern here. And this section here. So quad and then the X pattern. On the initial tune parameters, you can set a few things. I already set these default other parameters, but your air screw inch size to 3.5, cell count to 4, discharge voltage to 3.3, and so on, right? You'll also, later on, I would say do your accelerometer and ESC calibration. In fact, the accelerometer calibration due after everything is put together, not at this point. Same thing with the compass. ESC calibration, if you click over here, I do have it set to D-Shot 600, and that's what's working for me. There's also a D-Shot 300 value that I didn't use. 600 seemed to be the recommended in the latest firmwares and is working, so I left it at that. I don't think you actually need to calibrate. I'm getting mixed results when I Google on that. I have not calibrated yet. I'll talk you through a little bit about radio calibration when we get to that point with the receiver. But ultimately, to do the motor test that I just did and showed in the previous segment, you want to set all these different parameters in your flight controller. So there's table after table in here of the different setup pieces that you need. Let me just see if I can do a quick motor test. I wanted to get that beeping to stop, but it's not gonna. Anyway, we'll have to tolerate that. So if you go to your config tab over here and then you click on full parameter list, you will get all the different ArduPilot parameters. So what I want you to do is go through and set each one of these. So I'm going to type in bat monitor into this search tab, and you're going to set this one to a value of 4. So you can just go to the value tab and type in 4 and then say write params, right? If there were parameters that were changed, it would actually do that for you, or it would write it to the board. You want to set up your battery amps per volts and your current monitoring pins, and all of this will basically give you, these settings here will set up your battery monitors appropriately. Okay, what that'll get you is on your data tab, if you go back, you should start to be able to see the voltage of your battery here. So 13.73 volts, and how many amps and how much percentage is remaining in that battery. Okay. You can also just directly set the frame parameters. So this is how I do these as well. Frame underscore type should be a 1 and class should be a 1. And then we get to your ESC connector settings. These are necessary for the motor test that I did. So mote PWM type. This is the same as that drop-down setting on the ESC calibration. A value of 6 sets it to D-Shot 600. Okay, and then you need to set your servo functions to these values here, so the appropriate servo function controls the appropriate motor port on the board. So 34, servo 1 is controlling motor 2, servo 2 is controlling motor 3. That's necessary for the binding and mapping to work. You need to set your servo D-Shot ESC. And I set mine to 4. And you can always look at the values here too in the drop down. I set mine to BL-HELIS Bluejay plus EDT. Actually, I got that typo wrong. I think both work, 2 and 4. I was playing with both, but they both seem to work. And then I set NTF LED types and NTF buzz types to these values here. Ultimately, I just used the default, and if you click on it, I checked the, there's a D-Shot checkbox that was unchecked. When you check that and set it, that plus the defaults gives you this new number that you could just type right in here to set all the appropriate bits. Same thing with NTF buzz types. Okay, set that to a 3. All that did was turn on the D-Shot checkbox for me as well. Okay, other parameters you'll need will be for the ELRS receiver. So the ELRS receiver is connected to UART 6 on the board. So I set serial 6 protocol to the proper value of RCN here. Serial 6 baud rate, protocols, options, and RSSI type. So I needed to have these values set so that my receiver could properly talk to the flight controller and send and receive commands. And then I also had to set some RC mappings so that my controller would work properly. So with the inputs that were coming from my RadioMaster controller, I had to set pitch to 3, roll to 4, throttle to 2, yaw to 1. Ultimately, if your radio is set up a little bit differently, you might need to come to this radio calibration tab under the setup, and you can change your values, mess with your radio, like move the throttle stick up and down, and this throttle progress bar will show you how much of your throttle it's outputting there, right? From 0 to 100%. Same thing with your pitch, same thing with your roll and your yaw, right? So you need to make sure that you're seeing proper response on this page from your transmitter. Otherwise, your drone's not going to get controlled correctly. A couple other ones too I changed just to finish out this. If you want to just set all these at once while you set up your MicoAir, go for it, right? So for the GPS connections, under board safety default, there is no arm, disarm, safety button, so I got to disable that. And then I got to tell it that on serial port 3 is where the GPS is connected. And it gets a value of 5, which in this dropdown is GPS, and then GPS 1 type, I needed to set to auto. Okay. Video transmitter, set these properties as well. This will allow ArduPilot to overlay telemetry onto the video screen and output the appropriate data so that it all gets sent from your video transmitter to your goggles. Right? So that video transmitter is connected to serial port 2. I'm setting it to smart audio protocol, the baud for smart audio, and serial 2 options needs to be set to half duplex. I also enabled the on-screen display so that it will overlay the values. This next section for flight modes, a little bit optional. I have a 6 position button on my controller, and so you can set these. I'm setting it to channel 6. By default, ArduPilot sets it to channel 5. And from what I understand with the ELRS receiver, channel 5 is hard-coded to a, I think an arming bit or throttle cut type of thing. And so I had to move my 6 position switch to channel 6 so that I can configure the different flight modes. So on that, I have flight mode channel set to 6, and flight mode 1 is set to loiter. Flight mode 2 is auto tune. I use that at times. I might change that later to auto so I can run auto missions, and so on. You can also use the user interface to do that as well. If you go back to the setup tab and you go to your flight modes section under mandatory hardware, you can see all those settings here. Right, so loiter, auto tune, altitude hold, auto, RTL, and land are the 6 different modes I set up. And they're all mapped to one channel, right? Channel 6. And based on the PWM output that your radio is sending, it will then decide to pick an appropriate flight mode, right? And so your PWMs usually go from 1,000 to 2,000, and so this is how these map on my radio. I also set the RC failsafe, so if your radio dies or you go out a distance from your radio, your drone will do something somewhat sane, right? So I got the failsafe is turned on. Enable the throttle enable. So if throttle goes to 975 or lower, it's going to activate the RC failsafe after 1 second of not detecting throttle. Okay. So those are set so when you lose your radio, it will try to do something appropriate. And those, I believe, where did I set those? Sorry, I was trying to figure out what flight mode it goes into. So FS throttle enabled. It turns it on. If it loses throttle signal or the radio, it will RTL, return to launch. I also turn on a geofence. You can turn this on or off. The geofence just makes sure that the drone stays within a certain distance from you and can't go beyond that. So fence action, I set that to, actually it should be set to 4. So when the fence is breached, I want it to just break, right? Just stop where it's at. It was set to RTL. I don't want it to fly back to me when it hits the fence. Otherwise, that gets a little annoying. So when the fence is breached, it just breaks and kind of holds its position. And then you set your fence parameters. So the altitude max right now, I got these are in meters. I got set to, actually it looks like I didn't set these at all.
So I want to set that to 30 meters. Altitude min, I set to a negative number. That looks to be the default. Fence auto enable. I'm going to set to 0. Fence enable. Set to 1. Fence margin. And I got descriptions of what all these do next to the side. Set that to 3. Radius. So it looks like I set all these and just maybe missed a couple of them. Fence radius. I don't want to go beyond 100 meters from where I'm at. And fence type is 7. So those are the values that a 7 correlates to. So I'm going to write those. A couple changes I had to fix up. RC7 option, my RC7 channel on my radio, I have mapped to a switch output to channel 7 so that I can turn the fence on or off, right? So with that as a value of 11, you can turn your fence on or off that way. And then the last couple settings are for auto missions. I don't think I even set these yet. Maybe I did. WP nav speed. 500 centimeters per second. It defaults to 1,000. I slow it down in auto missions just so, I don't know, just for my own sanity, I guess. I don't like it moving super fast on its own. How fast it can go up, how fast it comes down in auto mode. So, and I'm just double checking that I set these. How fast it accelerates. So those all appear to be set. And then the last one that is set at times, this board boot delay is set to 3 seconds or 3,000 milliseconds, which is 3 seconds. So when your board is powered on, it'll delay initializing that board for 3 seconds, which kind of gives other peripherals, such as your GPS, a chance to power up and start getting initialized as well. I don't know how necessary that is. I do it on other drones, and it doesn't seem to cause problems. And in some cases, when I'm using the HERE GPSs, it was recommended. So I just put that on all my drones now. So that's the configuration that you want. Write all that to your drone. Unplug it from USB, unplug your battery, and reboot the thing. And what you're going to do is reconnect through a mission planner, and you can come back to your setup tab then. And under optional hardware, there is a motor test option that you can click on, and you can hit each motor, right? So motor A, B, C, and D. Motor A is going to control motor number 1, should be going counterclockwise, and vice versa. Control your throttle here, so it's going to go at 5% of its speed and for a duration of 2 seconds. So if you press the button, it should go ahead and spin your motor in the right direction. So you can also do this test all in sequence, which will go through motors A, B, C, and D in order, each one for 2 seconds at 5% throttle. So I would recommend you do that and test out all your motors. And then if you're at the same state as me where everything appears to be going in the right direction, then continue on with the video and let's start bolting all these electronics into the frame. I'll pick up with the next segment and start to show you that.
Okay, so now based on where we're at, we had the motors working. We were able to do a test. Wiring is a mess. We need to start installing the electronics into the frame now. So what I'm going to do is I'm just going to kind of take this out. I'll just leave it like that. I want to remove these prop guards first. So should be 3 screws on each that I'm going to go ahead and take out. And I need to remove those prop guards so I can run the wires through. And this will just be a quicker, easier way to do that. kind of leave it in there enough where the TPU piece stays in. But if I can get these other screws out, set those over here. All right, that lets me lift these prop guards up. And so what I'm going to do, flip it over a little bit here. Just going to move this TPU piece there. Okay, so what I'm going to do is we'll disconnect each one of these motors and connect it back in. These connectors fit really tight, which I guess is a good thing. All right, prop guards removed. Now we just kind of have the base frame. And so for installing this stuff, what I kind of wanted to do was put the video transmitter underneath the speed control. So untangle this a little bit. I'm just going to disconnect it all. Let's unplug that mess from the speed control. All right, so we're sitting looking like that right now. This video transmitter I found seems to fit best if I put it underneath the speed control, because that antenna is going to come out the back of the drone. And so I'm going to put it back as far as I can. And I need to make it far enough back so that this wire will go through the back. And I have some Velcro here. And I'm just going to cut a couple pieces off, and this is how I'll hold it in. All right. So we got this Velcro piece. I'm going to take the softer side and I'm going to put that on the video transmitter. Okay. And then the other side will go to the drone. We'll put that somewhere there. And it should give me a little bit of room where I can mess with it and move it forward or back if I need to. Okay. So we're going to be looking like that. Now, I think just to make this go together well, I'm going to put the prop guards back on with the wires run through it now. So I can make sure everything fits as I put it together. There's that side. I think for right now I'll just put one screw on each side. Oops. Just be careful as you screw it together, you don't pinch any wires or anything too. So I'm going to kind of keep double checking that as I go. Get that wire trapped in there. Okay. So my video transmitter is down. I just kind of got that coming through for right now. All the rest of the electronics are there. So now what I'm thinking is I'm going to run the connectors for these ESCs to the front and back in the little bit of space that's in there. I'm hoping it's all going to fit. Okay. Something like that on the front and back. And then something like that is what I was thinking. Now I should be able to take the flight controller and I'm going to reattach that. My hope was that I could just install it by flipping it over. Got a couple wires tangled up here though. So my RunCam is going to need to go to the front. Okay. And the receiver and GPS all need to go to the back. Take this RunCam connection and pull it up just a little bit. And then I should be able to put one of my screws in to start to hold this together. And I'll put one in at each corner. Okay. So I'm going to do something like that. So I'm going to pause it here for a minute, and I'm just going to put the rest of the screws in on the bottom, and I'll get the rest of these flight controller screws in, and then I'll pick up and show you what's next. So I just laid everything in here, and this is how it came out after I screwed everything together. So the speed controller and flight controller are mounted in the center, and I kind of just pulled the GPS off to one side, the ELRS receiver off to another, the antenna, the video transmitter antenna, and the power supply or power cable are going to the back. And then I got the RunCam just kind of laying off to the front right now. Now, one thing you'll notice is this USB-C port in here, you can't really get to it. So with the way that's in there. But I was digging through the parts that came with the Protek frame, and I found these three pieces in here. So it had like a little 90-degree USB-C connector that had a 90-degree angle to this 4-pin cable, and then it had this little guy in there as well, which seems to have two USB-C connectors and two 4-pin connections on it. So I tested it and it works. So what I'm going to do here is plug that into there. Right, so the 4-pin cable is into that 90-degree connection. And I'm going to go ahead and just put that in the USB-C port down here. If I can reach it. And I got the screws loosened up, so I was able to do that. And so that gives me a connection here, and then I'll leave that off to the side. I don't know where I'm going to run this wire to, but I know I'm never going to get at the USB-C connection in there if I leave it the way it is. So we're going to do that right now. It might be that it just hangs out the front or something on this frame. I don't know. So now I'm going to go ahead and tighten these back down a little bit. I don't want it too tight because I still want it to be able to vibration dampen. You notice there's a bunch of rubber grommets in both the speed controller and flight controller, and we want those to dampen the vibrations that are going to the IMU. Okay, but the thing you do have to do is tighten it down enough so that A, it's flat and level, and B, so that the top carbon fiber piece will fit and be able to be screwed down. So make sure everything is below the plastic prop guards, and then you can kind of test it as you go. Just lay the cables in the tray here. I'm going to lay that new one in there for right now. And you would just want to make sure that that can fit in over your flight controller and be flush and get screwed in properly. Okay. So that looks good to me. Maybe it's not quite level yet. Let's screw these back ones down a little bit. So I'm going to leave it like that. So next step is we're going to want to install this RunCam and get that mounted in the front of the frame here. So I'm gonna pause it real quick, try to figure out how that's going to mount, and then I'll start recording again and show you how I hook it up. For this next segment, we're going to try and mount the RunCam to the front of the drone. And I also think I have a plan for the USB connection that I talked about earlier in the video as well. So the RunCam should come with, in your box here, a set of screws and this little flexible plastic piece here. You're going to want to take that piece and line up the holes on the side and just push that on. It'll help to space it out so it fits in the drone a little better. The other thing you want is the orientation for the RunCam is where the wires are up. So you want it like that when you mount it as well. Now, inside the drone here, earlier when we built the frame, the instructions had us put these little standoff posts in here. Those are in the way of the camera, so I'm going to remove those. However, the width of that screw pattern happens to fit this USB connection perfectly. So I'm going to see if I can remove those posts and then mount this down to the bottom of the drone. So I'm going to need to do that first, I believe. So I'm going to go ahead and remove these posts. Okay. And it doesn't quite reach, I guess. So maybe if I can get these wires run under the speed control motor wires and around the corner there. Okay, that seems to reach enough. But my screws aren't going to be long enough. Okay, so the screws that come with that little plastic piece are not going to be long enough, so I'm going to remove those. I got those two screws, I got the plastic pieces. And it did come with more screws, some M2x7, and some lock nuts. But those don't appear to be long enough either. So I'm just looking through the rest of the box right now to see what else I had in here that maybe we can use. I don't know, these screws are probably not long enough too. So I think what I'm going to do is I'm going to grab some other M2.5 screws. Now, I'm wondering maybe these little tiny standoffs would work. And that might raise it enough above that TPU piece as well so that it fits correctly. So if I do something like this, Let's see. Had to go get some tools real quick. So maybe if I can use my needle nose pliers to kind of set that in. The hole's a little too small for this screw pattern. But I bet if I take a wrench or a hex driver, maybe I can screw it in from the bottom and kind of thread it a little bit more. No, not quite taking that either. Well, there's some drill bits here. And try and drill it out some. So I got a little cordless Ryobi drill. Get rid of the bits. Put a chuck bit in. And if I go with maybe a 7/64, see if we can make that work. So all right, got a couple of holes drilled there. Put these tools away. All right, so I drilled out those holes a little bit bigger here. So these little standoffs hopefully will work. Yep, they fit in there now. So perhaps I can take the standoff and set it in the hole. Okay, and I'm going to grab one of the nuts. I'll probably come back and put some Loctite on this later. I don't think it's really long enough to hold it well and grab the threads. Yeah, not really. Well, this may not be that great of an idea, huh? Okay, I was able to get the nut on. Barely catching though, so I'll for sure come back and put some Loctite or glue it or something. But this should let us see if this prototype's going to work here. All right, put the other standoff in. I'll try and get this nut to catch. All right, we did. Oh, didn't catch. Shoot, I can't get this one to catch. Well, maybe that ain't going to work with these standoffs then. So if I do something like that and just set it down there, I guess instead of using these screws, I got an M2.5 screw kit where I can grab a length that works, I guess. So I'll try, I don't know what I grabbed there. M2.5 by 10. So I'm going to have to screw it through the board to get it to bore the hole out a little bit. Try that. Got to screw in the board now. Run this down. Gives me a little bit more space on the bottom. Run nut. I'll put this other one in. I still don't know if the RunCam is going to fit if I put this in there, so we may be undoing all of this in a second here. All right, so I got two M2.5 by 10 screws screwed into that little board. Now if I push it through up there, kind of looking like that. Before I screw it the rest of the way on, let's try this RunCam. See if we're even in the ballpark of it fitting. Okay, so the wires are going to go up. This little plastic piece needs to be on it. That's going to go in. And what we need to do is make sure we can line those little holes up with it. Appears to be a little too tall still. It's unfortunate. That USB-C connection is still in the way. So this thing appears that we won't be able to let it live there. Kind of liked where that fit too, as a nice, easy USB access. Test it once more here. So these little holes on the side that line up with holes about the same size on the side of the drone. Wait. Maybe it is lining up. I think I might be able to get it. All right, so here's what I'm going to do. We got this USB connection, and I want to lock that down. There we go. So I'm looking for some those are M3 lock nuts. Okay, well, I don't have a lock nut that'll fit it. So I'll just go with a couple regular hex nuts for right now. And this is what we'll bolt that USB-C connection down with. Got a little bit of blue Loctite as well. So I'm going to put that on the threads. Put a little dab on each. That was way too much came out there. Okay, grab a towel real quick. Come on. All right, so got the one on. Okay, that's bolted down. Well, that took entirely too long, but let's see where we get next now. So we got a USB-C connection bolted in there. Whoops. Hopefully that's accessible. And it's just with these two bolts on the bottom. Now we got to go for our RunCam. So we're going to take this. It's going to come over. So that's the GPS. Here's our RunCam. I want the wires facing up. And I'm going to try these little screws that came with the RunCam. Came with a little tiny bag of screws. It looks like there's 2 short screws and 2 long screws in there. I'm going to grab the longer ones. Press the screws back with my RunCam box there. Got the 1.5 millimeter hex driver here. And what I'm going to try and do are line these holes up on the side of the RunCam. With these holes that are in the side of the drone and tighten it down. Now I don't know if this setup's going to let me tilt the camera enough though. Might be another drawback of this. Okay. Shoot. Okay, that mounts the camera in there. And there's just a screw in each side in here. There's a little tiny hole that'll go straight through to the camera. Now, this is mounted pretty flat with the drone. From what I understand, if you're going to be flying it fast, you really need it up at like a 30 degree angle, because when your drone flies, it's going to be pointing down as it pitches forward. So that's probably a little problem with this USB connection down there, is if I do ever want to fly it fast, I think that's going to be an issue for me. However, I'm just planning on flying this one slow anyway, so it might work enough. And I can point it down. It'll let me rotate it down, but not up because of that USB port that we put there. So that's about all the up that I can get. I guess if you want to go higher with yours, you're going to have to do something different with the USB port. I might have to end up removing it anyway. Okay, so that's how the RunCam works, and we should just be able to take the rest of this wire and bundle it up and kind of shove it down inside there. And that's how that part works. Oh, I got a little USB cable too. We can just try and see if that's gonna even let us plug it in. Yeah, looks like I can get it plugged in there. Okay. So that is that. Next step is we'll figure out how to get the GPS, video transmitter, and ELRS receiver all mounted in here. I'll pause here and be back to record that next segment soon. All right, on to the last part, the back half of the electronics here. So one thing I linked to in my wiki, and we'll try this mount out, is a TPU piece that's designed to hold a GPS. So this black one here has a spot where the GPS can sit into it. And this was the original one, right? This white one that came with it. So what we're going to try and do is our GPS cable is going to come out the back. I'm going to put that through the power connection. And we've also got to have our ELRS receiver in a spot where we can run the antenna into it. And so I'm not sure how to best do this. I think what I might try and do first is maybe run the receiver. So I'm going to pop these little plastic ends off the antenna, pulled them off, and there's little holes inside of this that are designed to hold the antenna. And I'm not sure. Do I just bend it to get it in or what here? But okay. So I kind of got that antenna run through there. I'm going to pop these plastic pieces back on. Okay, so we're going to end up going something like that. I know I need to get a wire for the GPS through. And there's a little hole there. So I'm going to go ahead and put that through next. See if I can pull it through. Okay. We need to get a power cable through, so I'm going to push that up through the hole here. And then lastly, our antenna needs to come through a little hole here. So this isn't easy. Kind of a lot of little wires and pieces to manage in this one little assembly. Okay, that seemed to go. So I got an M3 screw here, and I think I can get that into the antenna. On the antenna holder on the back, there's actually a threaded piece of metal that you can screw into that hopefully will hold the antenna, the video transmitter antenna, in place. I'm going to try it at least. When I was playing with it earlier, I can't screw both screws in though, because then I can't actually get the antenna to screw down. I would need a smaller screw or a button head screw or something like that, and I just don't have them. Okay. So if I do something like that, the antenna still mounts, which is good. Okay. I got my receiver coming out the back. I got the GPS wire coming out. Okay. And this thing is designed to sit there, and I think it's just going to flex back when we mount that. So our ELRS receiver is just going to get stuffed right in the middle there, I guess. We'll try that to start with at least. I'm going to try and bundle up those cables and just stuff it all in. Okay. Now, you can see I got the GPS detached here. There was a piece of plastic. Oh, here it is for the battery. So this, you can see it's rounded. So it'll fit the profile of this connector here. So I'm going to slide that on over the connector. And ultimately, this is what, I guess, holds it all together. This screws to the top of the frame through the carbon fiber and everything. All right, so we got that down. So, without the GPS installed yet, let's just dry fit this and see if it's going to work. This is really, really tight. We got the top here. Should be able to maybe put that down. And I'm just going to put a screw in the top right now to see if we're even close. I'm going to put 2 screws in the middle, actually, to hold this down and start to see what we're dealing with. So that's a little tight. These electronics are stuffed in there pretty tight. It's a pretty compact little frame. Okay, so it looks something like that. Now, this piece, I guess we'll have to flex that GPS mount and antenna, kind of stuff the power wire back in. This piece here is what screws to the back and holds all that together and down. This is kind of a cool frame all around, though. Oops. There we go. I wasn't actually in the right hole. It doesn't seem to be catching back here. There we go. Wow, together. Okay. So I screwed up here. I forgot. These middle ones are where the battery mounts go. So I'm going to switch these 2 plain screws to the front. Up here towards the RunCam. And the front isn't going down very flush right now. I think because when I screwed the RunCam in, it actually pulls the plastic sides in a little bit. So I'm pushing my finger a little bit to push it out. Just a tad. And that looks like it's going down now. Okay. And I'm hoping I can stuff this. It doesn't look like I'm going to be able to. I was hoping and banking on me just being able to stuff this GPS wire back through. But that don't look to be the case. But if I pull it out through the back here, I think I can do something with that. All right, so let's reconnect our GPS. Pull this wire back through from the bottom. Cross our fingers that it actually fits. Oh, it is. It did. Okay, good. Kind of just snapped in there and is tight. Now I got this wire hanging out the bottom, which sucks, but figure that out. I can maybe bundle that and stuff it in. Here's our GPS. Okay. So then we got these battery straps, these battery strap holders. I'm going to go ahead and just put those in these side pieces here. Put this next one in. Okay, this thing is back together. Try and do something with this real quick. I'm just trying to bundle it up and stuff it in its backside here. Battery goes right there. Plugs in, powers up. So if we put our Velcro strap over it, pull this up, this thing fully sits right in there. There we are. Let's tighten this down some. Put it in upside down, I think. Pull that up. Pull this tight. Loop that over. Come on, you can do it. And that Velcro's in. Voila! The finished assembly without props. Shall we power it on and see? Cross your fingers, no smoke. Need a little bit more wire. Okay, beeping is good. I see some lights blinking in there. Pretty sure I saw the GPS. Nope, the GPS has a little blue light on it as well. Not sure if you can see that. Motors seem to have initialized. Let's try one more thing real quick. Getting a USB cable. And I'm going to plug this in that front USB port. Let's go over to Mission Planner and see if a motor test will work. Okay, trying to connect right now. I got some telemetry. It's reading the parameters. Perfect. I'm seeing battery voltage readings. Here we go with the motor test. 15% for, I don't know what I got, 5 seconds per motor. Here we go. So A, B, C. I don't like the way that motor sounds. It's distinctly different. And D. Okay. We got a drone that spins its motors at least. So that's what that looks like. I'll go ahead and unplug it. Give you a couple close-ups. That's what it's looking like right now. Okay. There's the bottom of it. Back, our GPS and ELRS receiver. Front with the RunCam. Okay. So that's that. This has been a long video. I'm going to go ahead and stop this one here. And we'll try one of our next videos with, probably need to set up RadioPilot and the transmitter. So I think that's going to be next. All right. Take care, everybody. Thanks for watching. Real quick, I want to show a couple modifications I made. I was doing a little bit of flight testing and just checking things out and wanted to fill in a couple gaps just before this video ends. So one thing you'll notice is I took the GPS out of the back here. I was not able to calibrate it. It wasn't getting a good fix, and I think it's because the ELRS receiver and video transmitter are all right here and it's at an angle. So what I did was, for right now, I just I popped the top off and I just basically took the wires, and instead of going that way, I went out the front, and they're coming out the front of the RunCam right now, or right the gap right above the RunCam. And I just got a little bit of Velcro to hold it down for the moment. I'll figure out how to clean that up later, but when I did that, I was able to calibrate immediately. Another change I made, I was getting a really bad flight time with a 4S battery, so I bought this 6S battery, haven't tried it yet. It's just another Tattoo R-Line 1600 milliamp battery. I need to get a little bit bigger battery strap to hold it now. This isn't sealing right, so I got one of those on order. And I think the last thing just to touch on is, how do you mount these props? So these are motor pliers. If you notice, if you put a nut driver on the nut here, it's just turning the whole motor. So you got to hold the motor while you tighten that nut. And so these motor pliers are just off of Amazon. I don't know what that says, TCK FPV. And it's just wide grip, has some rubber type thing in here to keep you from scratching the motor. And what you can do is they'll just grab the motor with one hand, and then you can use your nut driver on the other and tighten and loosen. So you'll need to have some tools like that. And lastly, you need to make sure you get your props on your the right prop, the clockwise and counterclockwise props on the right motor. Okay, and so I'm not sure if these are labeled. If they are, you want your clockwise on the right motor and the counterclockwise on the right motors as well. If you remember, I showed the different motors spin in different directions. Easy way to tell, you want the high point of the blade at the, basically so it rotates the high, it goes from the high to the low, because that's going to push the air down and give you lift. So this one up here is a counterclockwise motor, because it's going to spin that way, because the blade kind of angles up, right? And so as it goes, it's going to push air down and give the drone lift. So these are just a couple of the changes I wanted to touch on. I'm going to then take this out and try and tune it up a little bit and film the next video. Show how I get it tuned. Oh, one more thing. There was a GoPro mount on the front here where the GPS is. That had to come off. So that was up here in the front, and it is no more. So I needed a spot for that GPS mount. All right, hopefully that wraps this video up now.